All right, folks. Lots of people always show lots of interest in my plasma machine, and I wonder why it's not more obtainable for folks to have a plasma cutter for themselves. Like, it's very affordable, but I mean, I figured out how to wire and put that one all together. So I feel, or my goal for this video is, like, I'm going to try to convert one, convert a plasma cutter, or sorry. My goal is to make a CNC plasma table for under $1,000 that pretty much anybody can wire and use. I'm trying to use, I went with, on Amazon, I bought a plasma cutter, and so, let's get this out of here. I bought, I think it's a 50 amp plasma cutter, and a CNC laser engraver. But my plan is, this is very attainable. This should just work. I should be able to hook this to this, and we should get ourselves a basic CNC function that a feller can do. I think I bought the biggest one they had, so I think it's almost a 2 foot by 2 foot piece you can do. So that should make this small enough that the average feller in their garage can do this. And I don't know. I think it should be pretty straightforward. I want to go through it in great detail along with the software, and so somebody can kind of buy the few parts and basically put a table together where they can start cutting their own parts at home. That's my plan. Hopefully. Hopefully it works out. That's our goal for the video. Anyways, let's open this stuff up and see what we got. This one's already looking like I'm gonna have to put it together. So for the plasma cutter, I think I'm gonna put links in the description to everything I got here, but for the plasma cutter, it's a 50 amp, apparently. And I got it for like 200 bucks. So how good this is gonna be, I don't know, but I'm imagining a feller's gonna wanna cut like 3/16 or something like that. Like, I don't know. It is a 110-220 model. I'm not expecting a lot, but I expect to at least cut things, right? Let's get our spare fittings. Here's your 220 110 plug and the actual unit. So again, we're not going for high production here. We just want this thing to, you know, the average Joe who wants to cut some consistently screwed up brackets for their car, like they're building a hot rod or something. At least that's the way I do it. Just trying to see what we all got here. All right. All right, so this is like the basic functions here. Plasma cutter. We'll hook that up later and try it out. For this one, I pretty much went out, looked on Amazon, found a laser engraver, and then I found the biggest one that I could. So this one I think was $500. Again, I'll have everything in the description there. This is all Canadian dollars, by the way. So this is the big investment, but I was trying to think of the easiest way to get somebody to hook up all the electronics and the motors, everything else, and I can't beat the price of this. Now again, I don't know how, like, this is not commercial use, like, for sure. I'm hoping this is gonna work fine. Otherwise I'll have a really cool laser engraver, eh? But it should be pretty straightforward to put together, I'm guessing. And the idea behind it is you could actually probably take it and move it on to piece. So that'd be kind of convenient, I guess. Well, we got a bunch of stuff here. I think the first thing I got to do is clear my workbench, and we'll try to put this thing together really quick. We should see if it can do laser functions. The idea I have is, instead of the laser, if it tells the laser to go, I'm going to tell it to run the plasma and turn that on and off. I'm just hoping that the wires are shielded so they don't interfere with the computer and stuff. So anyways, let's start putting this together and see what we got here. So we got this loosey-goosey put together. I ended up putting the longer legs on. Comes with, there's a whole bunch of spare parts in there by the looks of it. I am not going to mount the laser on there, but it's got the bits for the laser. This one's, it's got like an air assist or something with that. I don't know if, apparently it does a cleaner engraving or lasering or something. Anywho, we got this, it's hooked up. This does its thing, goes that way. This is like a manual height adjustment on here. As you can see, that goes up and down. So what I'm going to do is make a plate. I'm going to not cut this thing up that I can put it back to the laser thing. A, if this doesn't work, and then B, if I decide I actually do want to laser some stuff, or a feller wants to, they can use the laser cutter attachment on there, right? So I'm a little worried because this thing and the fan would plug into this little board. So I'm probably not going to attempt it right yet. What I'm going to do is get a relay. I'm going to put a relay into there just so it doesn't, I think it's going to draw too much power to hit that trigger. Maybe, maybe not. I don't know for sure. I'm just going to play it safe. I'm going to get like a $10 little relay. I might even just try like a 12 volt relay because the system is 12 volt. It might only feed 5 volts somewhere, but that might trigger just a regular standard relay. So what I might end up doing is we'll have to snip into this, but this is what tells the laser to fire. So if I run this to a relay, I can then tap it into the switch on the plasma cutter, and that'll tell it to turn on and off. So anyways, what I did is I had like one of these little collets, so that'll fit, the head of this plasma will fit into there. What I got to do is make a plate that we can bolt onto there, and it can hang down here. So then we're just going to set the height. This is a little high, but I don't know. For some reason, I just feel, I don't even know why I have it this high. Probably because it fits on my bench. I'm not sure why I have this. I might set up a little grate or something for it. But this thing would screw on with these 4 screws. So I'm going to make something that'll hold this torch. And then from here, this thing you can see goes up and down. So you'll be able to adjust your height, like just to get it the right amount off of what do you want to call it? Like stuff, your steel, whatever you're cutting. Oh, this thing is small. Curious how this thing will work. I think I'm going to try this out in a second. But anyways, I'll have to rig up something here. I guess it can't work with these long legs. This thing just probably won't have it with the cable the way it is. You can probably get a machine tip, but until we know this thing works, we're going to just do whatever we can do right now first. I think right now, because I want to get a relay, I'm going to wait. But I'm going to fire this thing up. We're going to spark it up and see what this thing does, what it can cut. My plan is 3/16, no more than 1/4 inch, honestly. It's a 50 amp. It should do lots, but I cannot imagine something like that has any kind of a duty cycle. So we're going to stick with a goal of 3/16. I'm going to move this for now. This is not doing me any good till I get that relay and we get my computer. I don't have my laptop. But let's move this out of the way. Let's try to test fit this thing, or test fire this thing, just for the heck of it. As far as putting this together, it was pretty straightforward. You've seen it. The instructions are there. It comes with the tools. There's little wrenches in there, stuff like that. There is a CD with some software, so we're going to try it and see if I can get that software to work. And like I say, I'm not worried about this thing at this point, so we will leave that off. I'll move this over to where my plasma or my other CNC is. Maybe I can just hook it onto that rig and we can test fire with there. Though I want to do it with a laptop, start fresh, kind of show you all the software as I go. Okay, let's try this thing first. I want to see what it can do. Alrighty, folks. I don't have very high expectations for this thing because, like I say, this is exactly like a $200 Canadian plasma. But hey, we'll see what happens. We got some 3/16. Turn this little bugger on. Go straight to 50. So we'll try it at the 40 amp mark. I don't know what it's supposed to be able to cut, but let's see what happens here. I think this is going to work just fine. We'll try it, Pierce. That's fine. A little bit of delay though. No, never mind. That thing works pretty good for a $200 plasma cutter. So what I really think is, because this thing just screws into here, all it is if we do a relay and this closes this circuit, I bet you it'll trigger this plasma to work. I'm just hoping it doesn't do anything crazy inside the machine. Let's be really stupid about it and just try this. Yeah. So all we got to do is, if you want to keep it as a plasma, you tie into here and run these two wires off. If I run these to a relay, they close the circuit, they're good. If I do that board to fire the laser, there's probably a plus negative on there. So I just want to shield the two from each other. It's good. It's gonna work, man. It's gonna work. All right, folks, I've been playing with the laser part. It's actually pretty cool. I dig it. I didn't have this centered right, but that's kind of neat. Anyways, I've been playing with this. I think I'm going to get this to work. Once I get this thing to go, do a test fire. I've kind of jimmy rigged. I'm going to rig up with a, like I can't say I'm doing this the proper way, but somewhere I'm using, an automotive relay. So I'm going to put this in. I will have to snip the one wire on here, but we'll be able to patch it back in again. This is what triggers it. I'm going to get it to turn this relay on, to which then we're going to pop in and do our pins to trigger the plasma. I'm going to make a plate to hold the plasma torch. That's my plan. To which this will sit here. It'll bolt on to this doodad. And it should just work. I want to just see if it'll do a test fire. My first thing. So I'm going to rig this sucker up. I got to put these pins in here. Then we're going to run a fresh wire up over into here so it can kind of do its dangle, do its thing, and see if it'll trigger the machine. If it arcs, that would be a win. And then maybe we'll try to cut something just for the heck of it, see what happens. And if it does, man, we're just like in business. It's working a lot. It seems to work a lot faster than I think. We might be able to use this light thing. I don't know. I'll explain the software shortly, but I kind of want to just see if I can get this thing to fire. If that works, and it works with my little relay thing, cool. Then we will jimmy rig this up and cut some stuff. See if it works. Well, it looks like it moves the torch around. All right, let's grab a piece of steel. We are going full Monty and going to see what we can do here. We got torch height, which we can adjust. I'm going to try to just set up a plate on here and we'll try to cut something relatively small on some light gauge steel and see what happens. Alrighty. Turn our little hot rod on. Give her some air. I don't know how much that plate is. Let's just go 40 psi, see what happens. I don't know if my compressor will screw it up. We got this thing set, our torch height is in there. We set her pretty close. I am going to try to use, if you can see, we're just going to, something they had in stock here. See what it says. Yeah, I'm not sure what's happening there. Oh, well, we had our first fault. But we proved proof of concept, it works. I think this thing wasn't happy. All right. This is what I thought was happening. Probably was losing its connection with the board. Let's do this. I'm not going to run it. I think it has to do with the ground. Oh. I can't let it go back. So I don't know if it was the compressor doing it, or it's what I was worried about, the plasma cutter with the high frequency thing. Like, it did do its motion, but it was that weirdness when my compressor turns on, weird stuff always happens. So we didn't obviously break anything because it's still working. Just don't know why it takes so long in those corners, but so you can see what I did is I actually cut the plug, and I've added these plugs in here. So what I can do now is I can take my laser and we can put it back on. I can plug it in and we're good to go. So it seems to work. I personally think it was my compressor. I was worried about that. We will try this again. I'm going to go a little lower on the amperage, and we'll give it one shot and see if this happens. Alrighty, gonna go for try number 2. Lower amps. I'm not gonna change the speed. Set home. We'll just lower the amps because we're only doing some sheet metal here, so. Okay, survey says, let's try this again. So that might be the only fix we need. What I did is I just tucked the wire into the ground circuit under there, like the electrode, just because it has the strike and arc. But if I run it and ground it to the table or back to my cable, it seems to have no issues. I'm going to try something else that has more holes in it, just to see, make sure that, oh, it should work. Essentially what I'm using is the software that came with the laser thing, but I'm using an online app. And again, I'll explain it. I'm just kind of going through it. I'm using Open Build's CAM software, so I'm using it. What I'm going to do is I'm going to go through, get all the settings for everything. Once I do more testing with this and make sure stuff works consistently, then I'm going to let you folks in on more of what's happening here. I got to do more testing because I want to make sure this thing doesn't just constantly screw up. It'd be really crappy to hand this off to you folks and then it's just constantly being a bugger of a thing and crashing all the time. I don't know what this thing is. It came with the design. I think this is what the little doodad for this laser table is. This is the company, but that worked okay. It's a little slaggy. I think it could go a little faster, but for what it is, I'm pretty happy. So far, setup isn't even that bad. The software, like I say, I've farted with a little bit, so as far as getting this done, this didn't take very long. Like you see me make this bracket, this is like a super simple bracket. All I did is I unbolted the laser from here. I made a bracket, bolted it to there. I welded that little collet on there, so I can stick my torch in it. So the only thing I don't like is this torch is sits funny. I think what I'm going to do is I'm going to go and grab my my very first plasma table. I still have it, but it's just basically a big table with the grates. So I'm going to grab it, and then I'll bring it over here to set this on, and then I can do some more testing with it that way. So I'm going to play with it some more tomorrow. Cut a bunch of stuff, design some things, cut a bunch of things, and then we'll see how this works. If this works good, then we're going to have a sit down, and we're going to explain how all this works to you. And explain the whole process. The whole thing. I want to break it down. Hopefully I'm not babbling too much. I'm actually pretty excited. This worked pretty good. Well, we are slowly winning the battle. I am, as much as I wanted to, and I've been trying to do free. I'm just trying to grasp that. I know a lot of the folks out there are not very tech savvy, and I think we're gonna have to we'll have to buy this LightBurn. I think that's the way to go. It's actually really cheap, so it'll add a little bit onto the cost, but I think we'll still be well under budget. It's only like, it's probably 85 US. I don't know what that is Canadian now, but anyways, it seems to be more or less an all-in-one, and I think I can set up the settings or give the folks the right settings for everything. I've been doing this with the 3/16. I'm doing about 40 amp. I got whatever my speeds and stuff kind of doodled down. I remember why I didn't really like this table. Like, this table I brought in was my very first plasma table, my round one. And what I did is, we have motors up here right now, like we're using these. I had a motor going down here with a threaded rod, with something to cover the threaded rod going over, and then I had something that came up on the side here, and that ran across, and I had a torch height, so this table doesn't seem level. So that's why I got things shimmed up, and I got to press this down. This is only a 2-axis, so it goes this way, but it doesn't touch off. So you might have to clamp your steel down. You know, if it warps, this thing is going to drag and screw stuff up. Anyways, that said, we've been going through, we cut a bunch of parts. There is a lot of slag with this setup, like dross or whatever you want to call it, on the back. And it does kind of cut a little wonky, but it's also a $200 plasma cutter. So it's doing the best it can. And I'm not going to concern myself much with that, because usually all you do is you give them a couple of those on the ground and it just try to knock all that stuff off. Anyway, we did that. We did a couple brackets. I think I got it dialed in for 3/16. It's cutting really nice. I'm pretty happy with it for what it is. You seen me do my multiple fail attempts till I kind of got things dialed in on some thicker steel. So we got that set. This one here's not the perfect, but this is I don't know why I cut it in 3/16. It's supposed to be for holding like tools, like die grinders and stuff. So you put your tool in there and slide it down, but the darn things won't fit in this sucker. I don't know why I made it so, why I did it on the heavy steel like that. Anyways, we're still practicing, so I'm going to keep going to try to get my consistency right. Or, like, you know, the cuts are going to be what they are, just because we are talking an El Cheapo cutter. I had a few little glitches where things stopped. I think what it is what everybody talks about, where you get some interference from the plasma cutter. All I did was I unbolted this thing off of here, and it seemed to clear up. So I don't know if all I got to do is just wrap my wire in tin foil just to try to keep some of the noise away from it. But it might be the computer itself, like this little whatever's in here, because it was bolted onto the aluminum frame. So I'm going to try to just make a plastic bracket for it, just to see if that keeps some of the zapping away from it, and keeps her going. Because I'd like to keep it all contained. Then we can at least take this off and drop it on stuff to cut. But I don't know. So far, I'm really happy. It's actually got, it's a really smooth motion. It's just, if you had a better machine, it would probably be a lot better. But hey, for the price, a feller can't complain. At least this is how my first, when I did this first plasma cutter, this is how a lot of my stuff was. This one actually can boogie pretty fast, but the machine just doesn't really keep up. My first one was that my Hypertherm, I kind of like had it all jimmy rigged onto here, but because it was just a threaded rod, it could barely go as fast as this one's going. Well, it probably goes about as fast as it did, but you notice when it finishes a cut, this one like Scooby's really fast around. I really wish my first one would ever done that. Anyways, I'm going to keep going, see if this thing's consistent, always works. And then I'll probably try some 1/4 inch. I want to get some settings for you guys there for 3/16 with this particular setup where you can go. Again, you're going to have problems where the cuts, they kind of come at an angle a little bit. I think it's just the nature of the beast when you're cutting so slow, and these consumables seem to burn up really fast on these. So I only have a couple I burnt one up. I'm still on the second one, but I don't know how long that one's gonna last. And I got one more, like this one here. You can see just like melted it. And I think that's the nature of these. The parts are super cheap though, so that's not a big deal. The consumables, anyways. Alrighty, we're going to do a breakdown of what we all did. So we have still our laser. That one is still functional and works. We didn't wreck anything there. All we did was we modified and put a plug on here so I can plug plasma in or I can plug the laser in. So we did that. I took the legs off. Anyways, I'm roughly going to go over the mechanical, what I want to do there, and then I will kind of I'll do the computer side of it. I'll do that in the house, I think, because I'll find a way to do a screen capture so I can show you folks everything. Quickly look at it right now, because I want to show you folks from installing to this LightBurn. It's a very simple app to use though, because when it's said and done, what it does, this whole grid will represent your whole cutting table. So that's kind of nice. And then for the most part, you folks will have to figure out how to draw stuff, but you can at least draw your parts. You'll be able to cut them on there, fine. I'm using the trial. You got 30 days with it. Otherwise, I think it costs you $85 is, I believe, what it is. So that'll be US. I'm sure that's US to get a license for it. So I'm going to base all my prices on US because that's most of the folks that see me up here. Everything I have right now, less the computer, Canadian, I have just under $800 into this all. I would have to add on like another $100 for this license. So that'd bring me to $900 Canadian. For you folks in the States, I think this is going to be $600 or $700, something like that. That's how much our dollar differs. What will you get with that? Well, you'll get a laser cutter. You will get a plasma cutter. You will, what else? Like I say, you'll have to purchase the software after. What did I do for modifications? It's not a lot. The only thing that a feller's going to have to do to weld or something is this little collet. I call it a little collet, but this thing will have to get welded to this plate, to which you've seen me make before. Other than that, you just drill some holes, you bolt it on. If you want to put your laser back on, you undo these 4 screws. You take these 4 off, bolt it back to your laser doodad, and stick it on there. And then we modified that plug. So this is the laser plug right here. Let me unplug this. Thank Trucker Bob. He sent me a bunch of these plug kits. Anyways, you don't have to use this. You can use any old plug. So anyways, this is the wire that would have been onto the laser. If you can get these ends, you can just make your own thing too. But anyways, I didn't have one, so I used this. I put a plug on there. I put this which goes to a relay into the front of this $100 or $200 plasma cutter that I got. I'm going to put a link. I'm going to have an Amazon link with the stuff. And there might be doubles in there, but it's just because some things, if you're from Canada, you can't buy it because it's on the US site, the US Amazon. So just so you know, if you see doubles of things. Anyways, what I'm going to do is I'll put an automotive relay, because if you got one of these, this does work, because this thing is sending out a 12-volt signal. And all right, I'm cutting in here because in editing, I did not stress this relay. It is actually important that you put a relay in there, because the laser, or the where we're pinning into, this sends a 12-volt signal out. And we don't want to send 12 volt into the plasma cutter. So you got to go 12 volt into the relay to close the contacts. And you want to use the second half of it just to close, like basically do the trigger on the plasma. I'm not sure, I won't doodle it out, but essentially you got to run the relay power on, which then clicks and engages the other side. Yeah, so automotive, I don't have that in the price, but they're like $5 on Amazon for a regular 12 volt automotive relay, and that's all you need in there, like I'm showing. The one I'm using is just a Bosch one from like I got it off an S10 or something like that. But anyways, you have to put that in that circuit, just so you know. Don't put 12 volts straight into there. Anyways, back to the video. So that'll work fine. So I just have this thing on the trigger side, it's 12 volt. It makes the relay go, and then this thing just closes the circuit on here. All I did is I didn't cut any wires, so I kind of just made a crappy looking plug. But now I can still plug this in and use this as a regular handheld plasma cutter, so I didn't modify anything on here. Like I say, this is just out of my junk pile, but if I had a nice relay, you could probably just mount this on the side and like screw it on there, and then you can kind of plug it in and out as you want. Like, I don't know, it's pretty straightforward. Did we do anything to the machine? We did. Other than that, that was the only modification. I had some interference, so I made this little block just to hold the control board away, because sometimes you would get a cut and it would go a little bad, like it would go a little wonky, and then you would lose a connection. So I'm thinking it was just because of the plasma cutter sending a frequency out, and it was like goofing with this box. So I made this little bracket. It's now some nylon, and then I just tied it onto there. So that got rid of that problem. The only other modification I did was, what is going on here? Was to my torch head. If you look under there, I just stuck something on here just to ground. Like, you could take a wire, tuck it under. I did a round electrode. It touches the tip, and I just have that going back, and it grounds with the other cable. Now, you might not have to do this. The reasoning for that is the tip has to be so far from the metal to properly strike an arc. And if for some reason your metal starts to warp and it can't see that, it's going to start fluttering, and then you'll just lose your arc. So if you do that, the thing could like fire way up in the air. It won't care. It'll burn up your tips, but it won't care. That said, the tips are super cheap for these, because I think Canadian, I can get a 60-piece set for $20. So anyways, but that's it for modifying on here. I'm really hoping I explained everything well and it just makes sense to folks. So I've cut everything from sheet metal. Not very good, because again, you got no torch height. So as you're going, stuff's going to start warping and you're going to struggle with it. This thing will hit it and it'll drag it around. This doesn't have any Z. Like, this controls your up and down. So you kind of set your spark gap, and it is what it is. So anyways, I made up a bunch of files I have for, and I'll go through that. But I have a whole bunch of files for different settings to get you started. And I pretty much just run what they recommend, the 75 pounds of air pressure. And I've been just lazy about it. And I just kept this thing at, it's pretty much max 50 amp. I just running it full out. I have run it at 40 down. I don't like to play with that. You can play with it. Don't matter. You'll I'll give you a base of what to do the settings into that software, where to do it, how to do it, and then where to start. And then you should be able to just start cutting right out of the box. So I have settings for everything from, I think I have sheet metal. I did some stainless, but if you're going to do artwork, if it's highly detailed, it's just not going to work out very great. It's but anyways, I got for 3/16, 10 gauge, 1/4 inch. I got all the basic sizes. I'll make a file, a text file. I'll put it in the description what the settings are as well. But yeah, I'm actually super happy with this. This was really cheap, affordable. You can easily build yourself some car parts. You know, there'll be a little bit of cleanup work, but it'll be nice. It'll be nice. This is similar to the way I started. And yeah, it'll be cheap. Cheap, and it's dual purpose, and you can stick stuff in there and like wood burn things, or maybe engrave stuff. I don't know how that all works, but anyways, I'm gonna bust out. I'm gonna go into the house. I basically want to explain how I install the software, what settings I do, and how to set things up so that you can start scooching onto there. Because if I stick my camera in front of here, I don't know how well folks can see, so I want to do a record off the back. Hopefully this video doesn't get too long, but anyways, let me do that, and then we'll do the old closing on this. All right, folks, we're gonna get started here. So I'll just re-record. All right, folks, I'm re-recording this because my audio was screwed, so this might be a little quicker than before. Anywho, the burn table thing there comes with a USB, and it has the software on it. So what you'll do is you'll see this here. So you're going to want to go in here, go to your driver. You'll want to install this first. You kind of do this dealio, click install, and it'll just, when it's done, it'll tell you it's good to go. Or it should. There you go. Telling you everything's honky-dory. Then we'll go back. There's this laser program. This one's free. If you do your own CAD, power to you. Just use it. Good to go. I'm setting this up just for folks who don't have, like, you know, they're kind of like me for the most part and aren't too tech savvy. So you're kind of going to just go through the whole setup, do your thing. When it's done, it'll be done. I'm going to fire it up. It's up and running. This is it. We are good to go. Mine, it just found it automatically, I think. If not, you might have to go down. Oops. You might have to go down here and just find my thing. It finds it and it kind of sets everything up. So we're like good to go. Make sure it's on here. If it's all working, fine. If the thing's powered on, it's yeah, it's just gonna. If it's powered on, it'll move around and do its thing, which it does. So perfect. So from here, we're going to do like a basic part. So we're going to make whatever, I don't know. We're going to make a part here. Let's say 4 inches by 4 inches. Perfect. We want to put a circle in there. So we're going to do this. I want a 2-inch circle. We do that. So we got a 2-inch circle. We are going to drop that in the middle. Ta-da, like that's our part. You have to imagine this represents that whole 2x2 table. So if you're stacking parts in here, you can kind of just do your whole thing. So anyways, this is here. If we go here, let's pretend we want to put in the middle of the table. Good to go. The machine doesn't know that. But if you click this button, and let me quickly get a camera and I'll show you what it'll do. All right. So if you click this button, and let's pretend you click right here, you'll see this thing's going to try to go to wherever it is on the table. You can fine tune it with these buttons. What I have found, if you're like me, I don't usually have the patience to wait for it to do stuff. I just grab it and I move this thing around to wherever I need it to be. But the problem with that then is the computer might give you an error when you try to run something and say that it's off grid or something. So what I do is I just click set origin, or I clear the origin, I set it, I make sure down on the bottom, I just tell it to print from this location or cut from this location, and then you just kind of hit start and it'll just do its thing. Before you do that though, you go into this cut section, and this is where I'm gonna have in the description, I'll have, like here's a good spot, like a good starting point for your cuts. I didn't spend enough time with this to fine tune anything, but I'll have this in the description. So this will give you a rough idea, depending on the size of the metal, where to set your speeds. So to change those, you're gonna go into this part here that says cut layers. Just, I call it cut. I go into here, I'll set my speed, make sure this is on, and then I go into, this is pretty much all I do. I click this one, I go into advanced, and here's where you'll change this, like you match this here. So we're pretending we're gonna do some 1/4 inch here, I think. Come on. We're gonna pretend we're gonna do some 1/4 inch. So I have it set up to like 16, this is like 1.6 seconds it's gonna pierce before it'll start moving. And then at the end, it'll wait 1 second before it'll do the next move. So I do those. I click this cut through. I don't know if it matters or not. But anyways, we do that. It's good. Make sure these two are checked on, otherwise it won't work. And then you just click start. And technically it will just go and do its thing. Now, if this is what it is, if it was my plasma, this would fire up the plasma and it would kind of just do its thing. So we're just gonna stop that now. But yeah, that's pretty much it. That's as simple as I can make this. Again, when you open this up the first time, I think this screen will pop up because I'm running on the trial. So you'll have 30 days. If you want to, basically, you'll have to pay for it, I guess, at some point. But you just click the button and you kind of do whatever it is. Like this is what it is for the license. It says it's good for 2 computers. So what that means is, I guess you can install it on 2 computers at any time. If you don't want one or you get a new computer, you just move it. So I guess it's a one-time purchase. You just get 1 year of updates. Other than that, that's pretty much it for this. Again, I always shuffle it around on the table or whenever I do that, but that's probably not the right way to do it. You can just go to the moves here and you can move this. You can see where it thinks it is on the table, but it only moves like just over 1/4 inch at a time. Like I can do this and tell it to move like 1/2 inch every time I hit the button. So yeah, it is what it is, and it works well. I'm adding in a chunk here because it's perfect for folks that struggle with like doodling CAD, and this seems to work. I think this will work. What you do, most people always draw a CAD picture of what they want. So we have like, you know, a part. We'll pretend this is a part. I think this is 2 inches by 3 inches. We kind of have our edge, and this is how a lot of people will make, and then they'll trace this out. What we can do now with this setup is, I'll just put this down here, and then we'll use our phone, try to get a very square picture of it, and we'll take a picture, and then we will bring it over to our computer. So what we can do now is open it in this program, and where do I have it? Put in downloads. So we got our picture right here. Boom. So this is our part. This is way too big and whatnot right now, but that's not the point. What we can do, because if we go back, let's go here. This is going to be the full size. See how big that is? That's like way too big, but that's no problem. What we can do now, though, is we can trace this. So if we take our pencil tool and we'll just start drawing to this, whatever it is. We can get however detailed we want. I don't know how there we go. No, let me start over here. All right. So we're going to just follow our doodle. I'm going to go really rough. Like it just is what it is here. I'm trying to do a really quick demo, but it'll give us at least the design that's in here. I think that's right. And then we'll we'll try to mirror this hole. We're going to pretend that's our hole. We can change the size after. So anyways, we've drawn our part. Now, if we go here, it'll show us our whole table. So that's cool. We go to our arrow. Let's delete and get rid of that. Now we have our part. We'll highlight the whole thing. Now we know it is 3 inches high and it's supposed to be 2 inches wide. Just make sure you don't have this on. So that should be pretty close to our part. I don't know what my hole is, but that's not really relevant. So we got this. Let's drag this down to here. We're gonna zoom in to see what's going on. But we could smooth this up. We could redraw the part yet again, you know, like if I wanted that to be more of a nicer circle. Like, I'm not going to get into this really, but we just have something that we took a picture of, we stuck into the program. It's done. Now I'm going to cut it on some 10 gauge. So we make sure this is on line. I'm going to go in here. 10 gauge I think is like 7, and I think I had like 1200 on here. So that should be good. So technically we should be able to cut this out. The only thing you have to mind is that there's a thing called a kerf, which is the width of the torch cut. So this part might get a little undercut. I don't know if we can change that in here. There is somewhere for it. I haven't really looked at it. Like here, there's an offset, so you can kind of inward or outward. We can kind of make up for the width of the plasma cut. We'll try this for the heck of it. I don't know, this might be too big or too small. Anyways, let's now go. I think we're set up on the table, so we'll be able to just start this. All right, part is still hot, but it looks like that works. We'll stick that one on top. Pretty darn close. I'm pretty happy with that. Have to work on the kerf part, but whatever. That's awesome. I like it. That worked good. Well, folks, in the big picture, I think I proved proof of concept that this does work. Take it for what it is. I'm in no way sponsored by anybody here for wrecking their stuff to do what I just did, but I was hoping, or my goal anyways, was that anybody should be able to buy these parts, put them together in a fashion similar to the way I did, and have a functioning, working 3D or plasma cutter that they can use to cut parts. I've showed how we can actually, at some point, if you've skipped the video, I even showed a point where we kind of take cardboard CAD and we make similar parts, because I know this is where people would struggle trying to draw this, but if you took a picture and trace it, I do want to stress, if you have weird cuts, just to make sure there are no open ends. If anything, don't turn your plasma on and just let it do its thing first, and you'll see, because if it starts cutting the outside, then you know you got an open point somewhere, and it's gonna, if it doesn't start doing cuts in the middle, it's not gonna work. Well, your part might fall out before it gets to the holes. Anyways, I don't know, I think this video is like pretty long, but I'm hoping this helps somebody try to build themselves a little CNC plasma table for cheap. Again, full disclaimer here, I don't really know what I'm doing, but I do fumble around and figure stuff out, so take it for what it is. At least it's not a crazy amount of money to throw at something to try. And worst case, if something doesn't work out for you, at least you have a really cool laser engraver that you can use for something. Yeah, I think that's where we're going to leave this one. I want to thank you folks for watching. And I guess if you haven't, I know I don't ask for it a lot, but if you don't mind clicking that subscribe button and hit notifications, that'd be great. Anyways, again, I want to thank you folks for watching, and we'll catch you on the next one. Later. Well, folks, I figure I would throw in a little bonus footage. So this is the exact same setup. The only thing I did is I pinned it into my Hypertherm here. It used to be CNC, so I just kind of patched back into my plug. All I did there is just attached into where my trigger goes. Anyways, a little bit of 10 gauge. We can actually, pretty much from what you're going to see is the difference between the cheap plasma and a quality or a brand name one here. The cuts are monstrously faster compared to the cheapie. And the cuts are so much nicer. You can see how high we can put the speed. I'm over double the speed to the other one. I just had to try it to see how it would be. You'll have to ignore my first cut because I had it about the settings of the $200 plasma, but these ones here, I did a couple cuts. This is my first one, and then like I ramped the speed up a bit, so you can see a little bit of dross there or slag. And then my second one, little worm, there's almost nothing on it. It's pretty big. Anyways, like I said, yeah, I just figured I'd add a bonus little bit to the end here to show if you have a plasma cutter and you want to tie into it, it works really, really good. I'm super happy with that. All right, folks, I hope you found this useful. Some of this, all of this, I don't know. But this is the actual end of the video. And I want to thank you for watching, and we will catch you on the next one. Later.